Good morning, guys. So the other day for geometry, we continued working with trigonometric ratios, sine, cosine, and tangent, to be able to figure out and determine the lengths of unknown sides. Today we're going to figure out how we can actually use trigonometric ratios to be able to also determine unknown angles, right? Because we can use them to analyze angles, we can use them to analyze sides. So this is the last thing we're going to be doing in terms of trigonometric ratios from these last few weeks on how to apply them. And what we're going to be using today is something that you may not have heard of. It's called inverse tangent ratios. And I'll get to it. I'm sorry, inverse tangent. Inverse trigonometric. I apologize for that. Inverse trigonometric ratios. And some of you may know already what the word inverse means. Some of you may not. It's okay. We will get to it then. So again, we are going to be working with trigonometric ratios, but we're going to be working with inverse ratios, and I'm going to show you how we use them. So whenever we have an equation, right? Let's say we have the equation 2x equals 8, and we want to solve for x. You would end up doing the opposite, right? The inverse operation. So opposite of multiplication is dividing. Divide by 2, right? And then x would give us 4. That's just how you solve equations. You always do the opposite, you do the inverse operation. Inverse means opposite. So when we're talking about doing inverse trigonometric ratios, we're talking about doing the opposite trigonometric ratio. Think of what we're going to do today to solve for measures of angles as solving an equation. Whenever you want to get the variable by itself, you have to do the opposite. You have to do the inverse, right? That's where inverse comes from. We're going to be doing the opposite, right? And what I mean by that, let me show you an example. Let's say we had this, right? Sine of x equals 13 over 15. Let's say we had that equation and we wanted to solve for x, right? We want to get x by itself. So right now, there's one issue. Next to x is sine, right? We have the trigonometric ratio sine, but in order to solve for x, we need to get rid of sine. That's where the inverse ratio comes from, because in order to get rid of sine, you're going to have to do the opposite operation, which I'm going to show you in a second. So going back to what we did last class, we had the trigonometric ratio, sine. The angle always goes with it, right? So sine of x represents our angle, equals, and then our side is, right? The opposite over hypotenuse, because that's just a formula for sine. The way we would go about solving for x, I'm going to simplify this first just to make it easier to see. First thing we do, we divide 13 divided by 15 just to make it easier. So it would be sine of x equals, it's going to end up giving us 0.87 rounded, right? And again, my advice to you, to make it truer in terms of a decimal, I would say just keep the decimal true to what it is instead of rounding. If we need to round, go with 2 decimal places, right? So now what we want to do, we want to isolate x, right? We want to get x by itself, which means we need to get rid of sine. So in order to get rid of sine, we have to do the opposite. We have to do the inverse. And what we do is the inverse, the opposite of sine, would end up being something that looks like this. That. And what this is, it's literally sine inverse. So whenever you see sine inverse, it looks like a -1. Sine inverse is literally the opposite of sine. So whenever you want to get rid of sine, you want to do the opposite of sine. The opposite of sine is sine inverse, right? And what we're going to do is the sine inverse of 0.87. So now when you get this, again, all we did, 13 divided by 15 gave us 0.87, right? Here. Right? And then from here, we went there. Just following the pattern, guys, just to show you. So we had sine of x equals 13 over 15. We divided it, gave us 0.87. And then to solve the equation, sine of x, we wanted to get rid of sine. Opposite of sine is sine inverse. So all we do, take the sine inverse of 0.87. And so sine inverse is on your calculator, you're going to see a button that looks like this, right? And then, in order to access this, what you're going to do is you're going to press the button that says second, right? You're going to press the button that says second, and then you're going to press the button that says sine. once you press the second end button that says sine inverse is going to show up. In order to get the inverses, you have to press the second button, okay? And once we do sine inverse of 0.87, it's going to give us that x equals 60.46 degrees. 60.46 degrees. And that's our answer, guys. Literally, if we solve for x, it would give us an angle of 60.46 degrees about, right? And again, the only way that we get rid of the trigonometric ratio, sine, we do the opposite. Opposite of sine would be sine inverse. Opposite of cosine would be cosine inverse, right? Opposite of tangent, tangent inverse. We're going to do more practice with this. But I just wanted to show you how to solve it purely, because solving is actually extremely, extremely easy, guys. It's just getting used to it. You know what I mean? Oh, sorry. Just so it's not so dirty over here. So now, let me draw you a figure, right? Again, that was just an example where it was given to us just to actually be able to solve it. But there are going to be other times where we have to set it up ourselves, right? So this is going to be 7, that's going to be 10, and that's our angle, right? Our angle there is A. We're going to end up wanting to solve for A, right? And so, same thing we've been doing, right? We have a right triangle, we can apply the trigonometric ratios. We know we're working with angle A because that's the angle we want to solve for. So now, set them up. In order to set them up, see what we have, right? We know from these two sides that are given to us, we know that the 10 would be the hypotenuse, right? It's the longest side. We know that 7 would be our adjacent side because it's next to A, right? Adjacent means next to. So 7 is adjacent, 10 is the hypotenuse. So if we have adjacent and hypotenuse, we know we're going to have to use cosine. And we know we have to use cosine because the formula for cosine is adjacent over hypotenuse. Can't use sine, can't use tangent, because sine and tangent both need opposite. We don't have the opposite, right? So now, setting it up like we did in the last class, right? It's going to be cosine of whatever the angle is. Angle in this case is A, equals, and then we just set up our ratio. Formula for cosine is adjacent over hypotenuse, so it would be adjacent, 7, over hypotenuse, 10. So again, cosine of the angle A equals adjacent over hypotenuse. So now, solve it just like we did before, right? We want to get A by itself. Before that, just to make our lives easier, we can turn this fraction to a decimal. So we could do cosine of A equals 7 divided by 10 gives us 0.7. Now, in order to get A by itself, we need to get rid of cosine, right? So the opposite of cosine, the inverse of cosine, would be cosine inverse. Cosine looks like a -1 of 0.7, right? And again, we always do the inverse because it's the opposite. If we want to get A by itself, we got to get rid of cosine. How do we get rid of cosine? Do the opposite. Opposite of cosine, cosine inverse. And if we take the cosine inverse of 0.7, it gives us that A is going to equal 45.57 degrees. 45.57 degrees. And we're done, guys. Again, the solving isn't difficult. The most difficult part is even setting it up. Because once you've set it up, again, it's just changing it to a decimal and then doing the inverse, right? Opposite of cosine, cosine inverse, right? Let's do one more, just to make sure that you guys actually get it. And again, just like I told you in the last class, the trickiest part with this is always just setting it up, guys. But please make sure that you're labeling everything correctly, just to be able to help you out. So we have this, again, it's always got to be a right angle, right? We're going to want to solve for h. We're going to make this 6. We're going to make this side 8, right? So, just like we did before, let's just label everything, right? We know we're working with angle h, because that's the angle we want to solve. So now, we have 8. 8 would be our adjacent side, because again, 8 is next to h, right? We know that 6 would be our opposite side. We know it's opposite because, again, it's across from h, right? So we have opposite, we have adjacent. So if we have opposite and adjacent, we're going to end up using tangent. And again, we can't use sine, we can't use cosine because we don't have the hypotenuse, right? For cosine and sine, we need the hypotenuse. So the formula for tangent is opposite over adjacent. So setting it up, it's going to be tangent of angle. Angle is h equals, and now set up the trig ratio, right? It'd be opposite over adjacent, so it'd be 6 over 8. Okay, all I did, I just set it up, right? We use tangent, whatever the angle is, in this case the angle is h, and then opposite over adjacent. Now in order to solve it again, let's transform 6 over 8 into a decimal. So we have that tangent of h is going to equal 0.75, right? And now we want to get h by itself, right? We got to get rid of tangent. Opposite of tangent, the inverse of tangent. So we're going to end up doing tangent inverse of 0.75. Okay? Opposite of tangent was tangent inverse. So now if we take the tangent inverse of 0.75, it's going to tell us that angle h is going to end up equaling 36.87 degrees. So we know that this angle here is going to be 36.87. The one thing I want you guys to always realize, the only time you use the inverses is whenever you want to find an angle measure. That's it. If you want to find an angle, you're going to have to always use the inverse. Always. Automatically. Only use the inverses when we're trying to find angles, guys. But again, if you have any questions, feel free to ask. Take care.